Here's something really interesting involving protons and neutrons. So protons, as you know from junior science, they're positively charged particles. Okay, they're found in the nucleus of an atom. And neutrons, if you recall, are neutral. They've got no charge at all. And they're also found in the nucleus of an atom. And I'm going to show you something really cool. The reason why a proton has a positive charge and a neutron has no charge at all. This is something I'll be teaching my Year 12s for Module 8, so the very last module, the last topic in Year 12 Physics. It's a really neat thing, really neat idea. So in 1968, at SLAC, so SLAC is actually an acronym, so physicists come up with really weird acronyms for things. SLAC is actually an acronym for Stanford Linear Accelerator Center. It's a massive, it's a particle accelerator at Stanford University in California. And what they found was really amazing in 1968. So what they did was they took electrons and they fired electrons through a proton. And to their amazement, the experimental physicists found that some of the electrons actually, so E for electron, right? Some of the electrons actually bounced back. They bounced away, they deflected in the material. Some of them, most of them actually went through, but some actually deflected. And they were able to figure out that protons in this case are actually made up of three smaller units, smaller particles. So in other words, protons aren't fundamental particles. Okay, they're made of even smaller things. And those smaller things were given the name quark. So a proton's made of three quarks. It was the physicist Murray Gell-Mann who actually called them quarks. And quarks, so it's like the periodic table, really, pretty much. The periodic table of particle physics is called the standard model of particle physics. And physicists to date have discovered a range of quarks. So there's something called an up quark, down quark, top quark, bottom quark, and charm quark, and strange quark. So 6 basic quarks in this standard model of particle physics, this framework. And protons are actually made up of 2 up quarks. So a proton, positive charge. Protons are made of 2 up quarks and 1 down quark. So here's a proton. If you look inside the proton, that's what you'll find. And I'll tell you why this makes sense. So an up quark actually has a charge of plus 2/3, and a down quark has a charge of minus 1/3. Let me show you a really neat maths trick. So an up quark plus an up quark plus a down quark. If you add up all these 3 quarks, the charges of the quarks, they should give you the overall charge of the proton, right? So an up quark is plus 2/3. We'll add another plus 2/3, and a down quark has a charge of minus 1/3. So 2/3 and 2/3, it's 4/3. Minus 1/3, you get 3/3, which is just 1. So a proton is a charge of 1 plus 1. That's where the plus 1 comes from, because of the 3 quarks that it's made of in this particular combination. Similarly, for a neutron, okay, for something that doesn't have charge, here's a neutron. It's made up of 2 down quarks and 1 up quark. And so 2 down quarks, so each down quark has a charge of minus 1/3. Okay, so minus 1/3, and you got this here, the up quark, plus 2/3. So minus 1/3 is minus 2/3, plus 2/3, and that's just 0. So that's why the neutron has a charge of 0. It's neutral because of the quarks that exist in this particular combination. 2 down quarks, 1 up quark. It's amazing how nature works. And it's amazing how the Stanford Linear Accelerator in 1968 was able to demonstrate this experimentally. So pretty cool.